In Activity 9 in the 11's lab from College Board, we start seeing some of the complexity within object-oriented programming. And this is really cool stuff. So 11's board is a child of the board class. The board is an abstract class, and it's also an aggregate object in that it contains other instantiated objects. It has a deck which has its own properties, and the deck is an aggregate object in it of itself because it holds 52 cards. All right, let's start trying to get our head around this a little bit, and then I'm going to explain some of the methods we went over in class. So first off, an abstract object is one that never gets instantiated. And again, the example that I always refer to is a mammal. There is no pure mammal running around. There's always a mammal and a dog. A dolphin is a mammal. It's never just a mammal. That's an abstract idea used to hold a lot of the common elements among other types of animals. So there are many different forms of solitaire. We're going to make 11's solitaire, but we could make many other forms. They'll all have a common element, a common board that, or an area in which you lay out the cards and you have functions. And so these common elements can be programmed here, and that way we can. There's going to be gaps though, like is that a legal move? If you select two cards, does it add up to the right amount? That's going to change depending on what version of this game we're playing. And so those need to be filled in by its children. So board can't run on its own. You need to extend board by using this property called inheritance, and that's what we're seeing here. Okay, now a board is always going to have a deck of cards, and so it's declared up here, and its placeholder is right there. Actually, let's pull this up, and we can look at on the board. You can see it has a deck right here, and this is where it's will store that variable, but it doesn't get created down here. The deck, it absolutely does get created. Okay, I'm lying. But when we instantiate the board, when we create a board, it needs these variables, and those variables come from the 11's board. You can see the 11's board, it has ranks, suits, and point values all pre-programmed for us, and so those will get passed into this constructor, and that deck gets filled out using the cards that we need to play this version of solitaire. So let's look at this deal method. Okay, this is one that's already programmed for us. It comes with the starting code. So if I look for the deal method, let's see here. Where is that? At least I thought. Oh, I'm in the 11's board, excuse me. So inside here, inside deck, we have shuffle, not deck, oh yeah, boy. Okay, board is what we're looking for, and it has a bunch of different methods, and here's deal. So you give it a location, and it will call the deck and deal a card into that spot. So let's look at that. Let's say I did 10 and an ace, and so that adds up to 11. I clicked on that one, I clicked on that one, and I pressed replace, and it would now need to replace these cards with new cards. So it'll call deal, and this is spot 0. 0, 1, 2, 3, 4, 5, 6, 7, 8. There's 8. Well, there's 9 cards on the board, and it starts at 0, ends at 8. And so if I press deal, I would say deal at 0. That would fill in this card by activating its deck's deal function. That would spit out the next card object in its array list of cards. In this array list of cards, it would pull the next card that's ready, and it would then fill in that spot with from the deck. So there are two methods called deal being used here, and this deal method will pull a card from this deal method, but this one's different because it will fill it in. It will fill in this cards array at the given spot. So this cards array is the array of cards that are actually being displayed on the board. But this cards is an array list, and it holds all of the cards that have been dealt and have not been dealt. So it's the master container. This one is going to have a fixed size. So the 11s board has a fixed size of 9. It will always be 9 cards. But we built the deck so it's more flexible. If we were playing with jokers and had 54 cards, this thing could handle it, no problem, because the array list is a lot more flexible. Because if we added to it or subtracted from it, it could adjust. Could we program it so it used an array instead of an array list? Yes, we could do that, but it's just maybe not as convenient if we wanted to make some adjustments. Alright, so make sure that you're sort of comfortable with how these objects are connected to each other. If you're not, come see me. Well, let's talk it out and make sure that we can get your head around this and you're feeling confident with it. Now let's take a look at some of the code that we were working on in class. So all of this is in the 11s board. Most of this is already started and built for us, and so we can see when we create the 11s board, we call the super constructor, which just means use my parent's constructor to build the deck. So this is the super method, and it's the super method because this 11s board extends the board. So this is its super, or its parent. Alright, so what we did is we first needed to start with is legal. So if a move is legal in this game, what has to happen is that either it needs to add up to 11, or we have a jack, queen, and a king. There's no king on the boards, but imagine there was. So jack, queen, and a king. So it has to be one of those two if we have a legal move. So we can do this in a single line of code. So I'm going to return right away, and I'll return a comparison that will compute to either true or false. So I'll return, and you can see down here that there's a method that says that will check to see for me if these two cards are a pair. And there's a method down here that checks for me to see if there's a jack, queen, or king here. So I can return this dot, and I do that only so it's convenient and it brings up all of the methods. And so return contains jack, queen, king, and it automatically helps fill in. It predicts the variable I'll need. So this has to be true, or contains pair sum 11 has to be true. And since I'm over this line, I'll just move down so it's a little bit neater. So either this is true or this is true, and if one of those is true, given the cards that have been selected, then the move was legal. So it's either a jack, queen, king, or a pair sum 11. And that's all. Now let's look really closely at this selected cards. It's an integer list. This is an integer is a wrapper class for an int. So all it really does is it holds a primitive int, a little lowercase int, and it holds that and adds on a couple extra features. And especially means it can be put into one of these flexible lists that has a little bit more functionality than a simple array. And we should note that it's only holding the index number. So if I selected this card and this card to add up to 11, it would store spot 0 and spot 0, 1, 2, 3, spot 0 and spot 3. It doesn't store the card, it just stores the address on the board. So the address in this array. So 0 and 3 from this array of cards. That means we're going to have a couple extra steps to access the card. Because we only have the address, we'll have to look up the card. So the first thing that we'll do if we're building contains pair sum 11 to see if the two cards added up to 11, we first want to see, well, is this size of this list just 2? If it's not 2, if it doesn't equal 2, then return false. It's not a pair to begin with, so we'll check that piece first. And if it's not a pair, forget about it. And so we'll only get past that if it is equal to 2. So we'll go here. So now I need to look up the cards. So if I did if I get the first number here, so get 0, that's the first item in this list. It's the 0 item, which in my example happens also to be 0 itself. So get 0 from selected cards will load in the number 0. And however, get 1, get the second number in this selection, will get the number 0, 1, 2, 3. We'll get 3. So I have location 0 and location 3 pulled out of this list. And now I need to get the cards themselves. And so I'll set up card 1, and I have this method that's built into the board. There's a card at. It will retrieve the card from the given spot. So all I can do here is I will load this card from spot 0, and it will be loaded, and I'll load this card from spot 3. Now I have the two cards. And the last step is, now that I have the two cards, do they add up to 11? So I'll get the point value from this, and I'll get the point value from that, and I'll add them together, and I'll return this comparison. Do they add up to 11? If they do, I've just returned true. If they don't, I've just returned false. So that will let me know if I contain, if the two cards that were selected contains a total value of 11. Okay. See, try that out. See if you can get your head around that. Tinker with this. We could totally combine these. So instead, if I wanted to make this more efficient, I could just replace this with the access right inside. So we could combine these steps. I've split them into separate steps only to try to pull this apart and make it easier to understand the different steps along the way. Okay. If you have any questions, let me know. We're going to continue on with this tomorrow.